Hello, Algebra students. Today we're going to be going over the Unit 4 guided practice. So hopefully you've been following the videos up to now, or at least been doing the units up to now, because a lot of that material is going to be very useful when you're going over this unit. So if you can, let's get open our Unit 4 packets, and let's go ahead and get started. And so the first thing we're going to look at is starting right here. Now, hopefully you remember from last unit that we can solve equations like this by simply trying to get n by itself, right? So we want to say n equals and then some number. Now, the way we would do that is first we would get rid of whatever's adding or subtracting first. So in this case, we're going to get rid of that plus 5 by doing a minus 5. And whatever we do to one side of the equation, we have to do the same thing on the other side of the equation. So that'll give us 3n on the left equals, and then this will give us 18. Now, I want to remind you that everything that I write, you should be writing down. So all this work that I'm writing, you should be writing as well. If you follow along, if you listen and follow along and write down everything I tell you to write and write down everything I write, you'll do very well. So then to get n by itself, you divide both sides by 3. Remember, 3n means those are multiplied, so we divide to cancel it. So that'll cancel here, so that'll give you n equals, and then 18 divided by 3 is 6. And there you go. Now, we're going to have equations coming up very soon that have 2 variables in them. Notice like this one, x plus y equals 10. Now, the thing about having equations with multiple variables is that this type of equation will have multiple solutions. Think about all the different things that x and y can be in order to equal 10, right? It could be 1 plus 9, or it could be 2 plus 8, or it could be 14 plus negative 4, right? So there's how many different solutions there are. There's actually infinite number of solutions to this equation, right? So but there's different x and y's, they have to add up to 10, but any combination you could think of that add up to 10 will be a solution for this. So you'd notice there are some solutions they wrote here. 8, 2, 7, 3, 6, 4, negative 12, 22. Okay. And we generally write the answers to this as coordinate points. So you could see that there. So for example, 8, 2, we write the x coordinate first, comma, and then the y coordinate. And we put it in parentheses like that. So this is what we call a coordinate point. And this will make a lot more sense as we continue to go. But hopefully you've seen coordinate points before and how to graph them on graphs. But if not, that's okay. We'll go over that as well. Okay. So let's look back at our equations. We said x plus y equals 10. That was the equation we had. Now, what if we choose an x value? So we're going to choose the x value to be 2. What would have to be the corresponding y value? Well, hopefully you know already that would be 8. So y equals 8, right? Because 2 plus 8 is 10. But there's another way we can just solve this as well. We could just subtract 2 both sides of the equation to get y by itself. That'll give you that y equals 8. So sometimes you can just look at it and figure out, okay, well, 2 plus 8 gives you 10. So y is 8, sure. Or you could solve it like we've done before by getting that variable by itself. So in this case, subtracting 2 on both sides of the equation. So here's an example, y equals 3x. Now remember, that means 3 times x in this case. And then we're going to use these different x values and find their corresponding y values. So it'll be y, for this first one, y equals 3 times x becomes 3 times 2. Again, I'm replacing the x with whatever the x coordinate is. So that'll give me 3 times 2, which is 6. So when x is 2, y has to be 6. What about the next one? Y equals, and again, I'm using this equation, so it's 3 times x, so 3 times 5 And I want to figure out what that equals. So that equals 3 times 5 is 15. So when x is 5, y is 15. And again, I'm just using this equation to help me with that. So I want you to do the last two on your own. So go ahead and give those last two a try. If you want, you can pause the video and work on those, or you can continue watching through the whole video and then go back and do all the ones I told you to do on your own. Okay, well, that was a simple one, but they get complicated, much more complicated. So let's look at this next one here. Here they give you 2 times x plus 4 times y equals 12. So what we're going to do is, what about if we replace the x with 2? What would the y coordinate have to be? So we're going to replace the x here with 2. So it'll be 2 times 2 plus 4y equals 12. So 2 times 2, that's 4. So this becomes 4 plus 4y equals 12. Now my goal is to get y by itself. I wanted to say y equals something. So I'm going to go ahead and subtract 4 both sides of the equation. This will give us 4y equals 12 minus 4 is 8. Then to get y by itself, we divide both sides of the equation by 4. That'll say y equals 2. So when x value is 2, the y value is also 2. So 2, 2. Now what about if we replace x with 0? So I'll do that one over here. So I'm going to use that same equation, except I'm going to replace the x with 0. So it comes 2 times 0 plus 4 times y equals 12. 2 times 0 is 0. So 0 plus 4y equals 12. Well, 0 plus anything, that's just the 0 doesn't add anything, right? So 4y equals 12. Then to get y by itself, we divide both sides by 4, giving us that y equals 3. So when x is 0, the y coordinate is 3. So 0, 3. Okay. So let's try plotting these coordinate points. So these were coordinate points that we found for this equation. Remember this equation? We saw it a couple examples ago. X plus y equals 10. Now we're going to graph some of these points that they had on that chart. Hopefully you remember there was an XY chart, and we had 8, 2, 7, 3, and 6, 4, where these were 3 of the points. And let's go ahead and graph these points on this chart. So when we're graphing a point, we want to go on the x-axis, 8, and then on the y-axis, 2. So the x-axis is this horizontal axis here. Okay, this is the x-axis. Notice there's an x at the end of that arrow. The y-axis is the vertical one. So when I'm graphing the point 8, 2, what that means is I go 8 on the x-axis and then 2 on the y. So 8, 2 is 8 on the x, 2 on the y. So I'm going to go and put a point right there. All right, notice it's 8, 2. So 2 on the y, 8 on the x. Now let's graph the point 7, 3. So on the x-axis, I go to 7. On the y-axis, I go to 3. So I go up 3. 1, 2, 3. Now let's graph the last point, 6, 4. 6 on the x, 4 on the y. Now, I want you to notice that these points that we just drew, they actually form a straight line. Okay? This is a very important concept. So what this means is when I see this line, it could actually tell me additional solutions to this equation. So for example, 5, 5, you see that that's on the line, 5, 5. Well, isn't it true 5, 5 works for this equation, right? 5 plus 5 is 10. Also, any other point on this line would also be a solution for this equation. So you can see another point here, for example, 10 comma 0, that's right here, 10 comma 0, 10 on the x, 0 on the y. But that works right here, right? 10 plus 0 equals 10, right? You can see every point on this line will be a solution to this equation. And that's one way we know that we did it correctly, is that these points that we have here, they should all line up. So all the points that we used in this equation, they all line up, always. At least for this unit, all of the points will line up on each equation. So let's try another one. This equation is x plus y equals -6. And so you can see these are various points that work for this equation. Notice -3 plus -3 equals -6. So -3 comma -3. -4 comma -2, well, that works as well. -4 comma -2. -4 plus -2 is -6. And then this last point they have, -8 comma 2. So -8 plus 2, yeah, that's -6 as well. So all of these points work for this equation. All of these points are solutions to this equation. So let's go ahead and graph these points. So -3 comma -3. So on my x-axis, I want to go to the left 3, right? So on the x-axis, I'm going 3 to the left. And then on the y, I'm going down 3. So 3 to the left and then down 3. That's this point right here is -3, -3. 3 to the left and then 3 down. Then -4 comma -2. -4, -2. Next point, -8 comma +2. So -8 on the x and then +2 on the y. Notice that all three of these points, they do form a straight line, don't they? They all lie on this straight line. And that's one way we can kind of check our work, is that we know we plotted the points correctly if they form a straight line together. Okay. And again, any other point on this line would also satisfy this equation, right? So if I did, for example, let's look at this point. This is -9 comma +3. Well, -9 plus 3, yeah, that's -6 as well. So any point on this line would also be a solution for this equation. Now let's talk about quadrants. So when you see an XY coordinate grid, you have basically you're split into 4 parts, 4 quadrants. So the top right quadrant, where the x values are positive and the y values are also positive, right? This is your quadrant 1. And then it kind of just goes counterclockwise from there. So this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. So again, quadrant 1 has positive x values and positive y values. Quadrant 2 has negative x values and positive y values. Quadrant 3 has negative x values and negative y values. And quadrant 4 has positive x values, but negative y values. So when we look at a coordinate point, we want to say, well, what quadrant is it in, right? So right here it says, which quadrant are you in? 1, 2, 3, or 4. So 3 comma 2. So 3 comma 2 is right here. Okay, that's in quadrant 1. So 3 comma 2 is in quadrant 1. What about -3 comma 2? So -3 on the x, 2 on the y. Okay, that's going to be in quadrant 2. What about -3, -2? So -3 and then down 2. Okay, that's in quadrant 3. What about 4 comma -1? 4 on the x, -1 on the y. You always do your x-axis first, then your y. Okay, that's in quadrant 4. Okay. I want you to try to do 5, 6, and 7 on your own. Just tell me which quadrant you're in. Okay, let's move on. Okay, whatever. So let's take a look. Here we have a list of x and y coordinates, and then we want to figure out which equation produces these points. Okay, so we can kind of check them one at a time. So if I'm using, let's just see if this first equation is correct. So this one says y equals 3x. So if this first equation is correct, then these points will produce true statements. They'll produce accurate statements. So let me just try this first point, 4, 8. I'm going to try this first point on this first equation and see if it works. So I'm going to replace the x with the x coordinate, and I'm going to replace the y with the y coordinate. So this will be replacing y here, that's 8, right? Because I'm replacing y with the y coordinate, equals, and this is 3 times x, so 3 times 4. Is this accurate? 8 equals 3 times 4? Well, no, that's not accurate. 8 does not equal 3 times 4. 3 times 4 is 12. So this will not be the equation for these points. Okay. Let's try the next one. Y equals 2 times x. I could use that same point once again. I could use that same point over and over again. So I'm going to replace the y with 8 and replace the x with 4. Is this accurate? 8 equals 2 times 4? Well, yes, that's accurate. So that's good. Now, I don't want you to just check one point. I want you to check at least 2 points. Okay. You always have to check at least 2 points because there might be multiple equations that have this first point, but only one of the equations will have multiple points. So let's go ahead and check a second point. Let's go ahead and check 6, 12. So I'm going to replace the x with 6 and the y with 12. So that's 12 equals 2 times 6. Is that true? Yes, 12 does equal 2 times 6. So yes, multiple points work for this equation. So I know that that's the correct equation. And you could check all the rest of the points too. I just chose the first 2 points, but you could have chose the last 2 points. That's fine. Or any of the 2 points. That's fine. All right, let's try this next one. So again, I'm going to try each of the equations to see which one produces these coordinate points as solutions. So I'm going to try this first point, 5, 12. And so I'm going to replace the y with 12, and I'm going to replace the x with 5. And I'm going to check which of these equations is going to give me the correct solution. Okay, so let's go and try this first equation. So that would be 12, again, replacing the y with 12, equals 2 times 5, again, replacing the x with 5, plus 5. Okay, so that would be 12 equals, and then 2 times 5 is 10. 10 plus 5 is 15. So is that true? Are these equal? No, these are not equal. So that means this is not the correct equation. Okay, I'm going to use that same point, 5, 12, but I'm going to try in the next equation. So that would be 12 equals 2 times 5 minus 8. So that'll be 12. And I want to see, does that equal 2 times 5? That's 10. 10 minus 8 is 2. So are these equal? No, these are not equal either. So that means this is wrong too. Let me try the next equation. And again, I'm going to use that same point. So that'll be 12 equals 2 times, and I'm going to replace the x with 5. And then it says plus 2, right? Plus 2. So this will be 12 equals, and then this is 2 times 5, that's 10. 10 plus 2 is 12. Oh yes, that equals, right? 12 equals 12. So I know that this first point does lie on this line, okay? So this line, the line that would be produced here, this point would be on that line. But remember, it's not good enough just to check one point. I have to at least check another point. So I'm going to check the second point here. Okay. I'm going to write it on this side though. Okay. So I'm going to replace the y with the y coordinate. So that's 24 equals, and this would be 2 times, and I'm replacing the x with 11 plus 2. Let's see, is that true? 2 times 11, that's 22. 22 plus 2, well, that's 24. Yes, so this point worked and this point worked for this equation. So I know that this is the correct equation. Okay. Okay. Once you find the correct answer, you don't need to check the last one. Okay. Let's go ahead and try this one. I'm going to at least check the first equation for you, but I want you to check the rest of the equations to see which one is the correct answer. So to check the first equation, I'm going to replace the y with, I'm going to use this first coordinate point, 5, 19, and I'm going to replace the y coordinate with the y coordinate here. So that's 19 equals 5 times x, so that's going to be 5 times 5, and then plus 2. Okay, so that'll be 19 equals, and 5 times 5 is 25. 25 plus 2 is 27. So is this accurate? No, these are not equal. So that means this first equation is not correct. Okay, I want you to go through and figure out which of these equations is the correct one. Okay, now again, remember, don't just check one coordinate point. You have to check multiple. Okay, actually, let's go and plug into the second equation. I'll show you what I mean. So replacing y with 19, sorry. So this would be y equals 2x plus 9. So I'm going to replace the y with 19 equals, and I'm going to replace the x with 5. So that's going to be 2 times 5, and then it has a plus 9. So this will be 19 equals, and this will be 2 times 5, that's 10. 10 plus 9 is 19. Okay, that's good. So that means that this first point is on this equation. Okay, this first point is a solution for this equation. Now let's check this second point, because remember, we always have to check at least 2 points. 4, 15 is what we're going to check. So I'm going to replace the y with 15 equals 2 times 4 plus 9. Okay, so that'll be 15 equals, this will be 8 plus 9. Okay, but that's 17. Are these equal? No. So that means that even though the first point works for this first equation, the second point does not work. So this is not the correct answer. Remember, whichever one's the correct answer, all of these points will work for the correct answer. So that's why you always have to check at least 2 points. You always have to check at least 2 points, because sometimes one point will work for the equation, but then the other points won't. Okay, remember, the correct equation, all of these points will work for that correct equation. Okay, this next one here, would not produce a line. Okay, this one's a little bit different. It won't produce a line, but notice we could still figure out which of these equations is the correct one, because all we'd have to do is replace the x and y coordinates with the x and y in the equation and see if it ends up being equal. Okay, so let's go ahead and try that first point, 4, 17. So, and let's try this first equation. Replacing the y with 17 equals, and replacing the x with the x coordinate. So this says x squared, so we're going to have 4 squared. And then plus 1, because the equation has a plus 1. So that'll be 17. Does this equal this? So 4 squared, remember that means 4 times 4. So 4 times 4 is 16. 16 plus 1 is 17. So yes, that does work. That's good. But remember, we always have to check multiple points. You have to check more than one point. Okay, so let's go ahead and check the second point here, 7 comma 50. So I'm going to replace the y with 50 and replace the x with 7. So this will be 7 squared plus 1. So what's 7 squared? Oh, okay, well, that's 7 times 7. That's 49. 49 plus 1 is 50. Okay, so that does work. So that means that this is the correct answer. Okay, so that means this is the correct answer. Y equals x squared plus 1. All right, this is the same deal, except they wrote it vertically with the x and then the y, but it's the same idea. Replace the x and y coordinates in these and figure out which of these equations would produce this set of coordinate points. So let's try the first equation, y equals x over 2 plus 3. I'm going to try this first point here. I'm going to replace the x with 10 and the y with 6. So this will be 6 equals 10 over 2 plus 3. So that'll be 6. Does this equal? And 10 divided by 2, well, that's 5. 5 plus 3 is 8. So are these equal? No. So that means this is not the correct equation. Okay, let's try the second equation. Again, I'm going to replace the x and y. The x I'm going to replace with 10. The y we're going to replace with 6. So this will be 6 equals 10 over 2 minus 5. So that'll be 6. Is this equal to 10 divided by 5? Or sorry, 10 divided by 2, that's 5. 5 minus 5 is 0. So these are not equal. So that means this is not the correct equation. So our answer must be this last one, but let's just double check. So I'm going to replace the y with 6 and replace the x with 10. So that's 10 over 2 plus 1. So that'll give us 6 equals 10 divided by 2 is 5. 5 plus 1 is 6. Okay, that's good. So this first point will be a solution for this equation. Let's go ahead and check at least one more other point. So we're going to check this one. And again, you could choose any point you want, but I always just choose the next point. So I'm going to replace the y with 11, and I'm going to replace the x with 20. Hopefully you could already see that this is good, right? So that'll be 11 equals 20 divided by 2 is 10. 10 plus 1 is 11. So we see that multiple points do work for this equation. So that means that that is definitely our answer. And again, I want to emphasize that if you graphed all these points, graph these 4 points on a XY coordinate grid, these points would line up. These points would all form a straight line. Okay, here's an example. Let's go ahead and read what this is saying. So John, an 8th grader, came up with the hypothesis that students who text message a lot sometimes have difficulty concentrating on their homework for long periods of time. He came up with this theory when he noticed Sue, a girl in his class, sends 50 text messages a day and can only focus on her work for 20 minutes at a time without looking at her cell phone. John surveyed 5 students in his class and asked how many text messages they send per day. He also asked them how many minutes they can study at home without any interruption. That means no looking at the cell phone or iPods. This was written a while ago. I doubt most of you have iPods anymore since your phone plays music now. But anyway, He decided to label his results. X is the number of text messages a person sends, and Y is the number of minutes on homework without interruption. So you can see Sue in the example. She sends 50 text messages and she can only concentrate for 20 minutes. Okay, so that's how you read this. X is the number of texts, and then Y is however long they can concentrate for. So you can see in Brittany's case, she sends 20 text messages and she can concentrate for 80 minutes. Okay. And so we can turn these data points into points like coordinate points. So 50 comma 20. So that means 50 text messages. You can concentrate for 20 minutes, so on and so on. Now let's go ahead and graph these points on this grid here. Okay, so they have the points down here as well. 50 comma 20 for Sue. So 50 on the x-axis. Okay, that's right here. 20 on the y-axis. Okay. For Brittany, 20 on the x, 80 on the y, 20 on the x-axis, 80 on the y. So that's where that coordinate is. For Mike, 30 comma 60, 30 comma 60. Notice these points, they're already forming a straight line, aren't they? That's good. For Scott, 0 comma 120. So 0 on the x, so not going anywhere to the right, and then 120 on the y. And then Chelsea, 60 text messages, 0 minutes of concentration. Okay, great. And as you can see, all 5 of these points form a straight line, don't they? Okay, so let's go ahead and make that straight line. So hopefully you have a straight edge at home, like a ruler or something else that's flat and straight that you can draw lines with. I don't have a straight edge, so mine is kind of wiggly. But actually, that's pretty good. Yeah, that's a pretty good job. But yeah, if you've got a straight edge, I would suggest using a straight edge for drawing all of your lines. Okay, that'll make it much nicer to look at. Much, much nicer to look at. And easier to grade for your teacher as well. So we want to find an equation that basically, what would be the equation for this line? So remember, it's just like what we did before, where we were trying to find the correct equation that these points are solutions for. But here it's not multiple choice, right? We can't just plug it in and find the correct equation. How do we find the equation without multiple choice? Well, that's what we're going to cover. So the first thing you want to look at when you look at to find the equation is you find the slope. Okay. So here they're going from Brittany to Mike. So if we look at Brittany's point, that's 2 comma 80, and Mike's is 30 comma 60, we can find something called the slope. Now you don't have to use these 2 points. You could have used any 2 points on the equation. But basically the way you find slope, and usually we denote it with an M. So right here, we're going to put M. And then plot M times X plus, and then B is what we call the Y-intercept. So this is the first form of a linear equation you're going to see, and it's the most common form you're going to see. So this is, I want to rewrite it, Y equals mx plus b. And it's important for you to know that the M is the slope of the line and the B is the Y-intercept. We'll go into detail about what those things mean, like the slope and the Y-intercept. But for now, just think of the slope as how steep your line is, okay? And what direction it's going, okay? So your slope tells you, is it not very steep or is it really steep? or is it going, this way, or is it going that way? That's what your slope tells you. The B, the y-intercept, that tells you on the y-axis, where does your line cross the y-axis? Remember, the y-axis is the vertical one. So the B is wherever your line crosses that y-axis. So first, let's find our slope, though. I'm getting ahead of myself. First, let's find our slope. And the way we can find the slope simply is by doing the rise over run. So our slope, which is usually we denote slope with these m, with an m, equals the rise over run. The rise over run. Okay, so you take however much it rises, then divide by however much it runs. So if you're going from Brittany's to Mike's, the increase in text messages from Brittany's to Mike's. So it went from 80 to 60. Okay, so 80 to 60. The rise, that's actually down 20, right? So the rise, you look at the y coordinates. So that went down 20. And the run, you look at the x coordinates. So it went from 20 to 30. Well, that's an increase of 10, right? So the amount that it rises is actually down 20, but then it runs plus 10. If we simplify that, that's just -2, right? -20 divided by 10 is -2. So your slope in this case is, I should probably just put -20 here. The increase in text messages, oh, they're doing it. Yeah, the increase in text messages should be, I'm putting this in the wrong spot. The -20 belongs down here. And the increase in text messages was 10. Okay. So the change in y, so the change in the y values, that's the rise, is -20. And the run is the change in the x values, so that's 10. So for every 20 minutes, for every 10 text messages, you are able to concentrate 20 minutes less on homework. That's basically what this is saying. So now we use that point. We use the point from Brittany to Mike, but we didn't have to use those 2 points. We could have used from Mike to Chelsea. What was Mike's point again? Mike is 30, 60, and Chelsea is 60, 0. 30, 60, and then Chelsea's is 60, 0. Okay. So what was the increase in text messages per day from Mike to Chelsea? So that's the increase in X. So what's the increase in X? That was plus 30, isn't it? What was the decrease in homework, right? So here it went from Mike can concentrate for 60 minutes, and then Chelsea can't concentrate at all. So that's down by 60 minutes. Okay. So the rate of change, or in other words, the slope, is the change vertically. So the change in the y coordinates. So it went down 60, divided by the change in the x coordinates. So that's up 30. So -60 over 30, well, that gives you -2. So our slope is -2. Notice it's the same slope that we got for this one here. Okay, so whether you're going from Brittany to Mike or Mike to Chelsea, you get the same slope. And that's key. For every linear equation, so in other words, for every line, you should have the same slope throughout the entire line. That's important, okay? If it doesn't maintain that same slope, then it's not a line, okay? So lines always have the same slope throughout their entire length. Okay. Now, remember, Do you remember I said to find the equation, it was y equals mx plus b? And the m is the slope. So in our case, that slope is -2, right? We already got that. So that's why it says y equals -2x, and then plus the b is the y-intercept, okay? So the y-intercept, if we look at our line, we can see the y-intercept. So where does our line cross the y-axis? Okay, it crosses at 120. So that's your b, that's your y-intercept, okay? So right here where it says, what's our equation? Y equals mx plus b. Our b will be 120. Okay, so this is the equation of our line. Y equals -2x plus 120. So it's y equals the slope times x plus whatever the y-intercept is. Okay, y equals slope times x plus the y-intercept. So if a person sends 0 text messages per day, how many minutes are they predicted to be able to focus on their homework? So they send 0 text messages. 0 text messages. So what would be the y coordinate for that? So if we send 0 text messages, that means we're replacing x with 0. So that'll be y equals -2 times 0 plus 120. So someone who sends 0 text messages. So the x value is 0. So this will be y equals, what's -2 times 0? Well, that's 0 plus 120. Okay, well, that equals 120. So if someone sends 0 text messages, they can concentrate for 120 minutes, at least according to this equation. It's showing that you could also flip-flop this and put the 120 first. I wouldn't suggest doing that usually. Generally speaking, I like to see the thing with the x first. So I'd rather it be -2x plus 120, personally. But you could always check, since we have y equals -2x plus 120, we can double check and use one of these other points to make sure that that point is a solution for this equation. So the point there we could check is Brittany's. They want us to check Brittany's point, 20, 80. So here's Brittany's point, 20, 80. And again, you could use all these points should work on this equation. Okay, so what we're going to do is we're going to replace x and y with 20 and 80. So let's go ahead and rewrite this, replacing x and y with 20 and 80. So the y coordinate will be 80 equals -2 times x, so times 20, plus 120. So if this is the correct equation, then this point should work. So this will be 80 equals, what's -2 times 20? Okay, well, that's -40. Then we have a plus 120. So this will be 80 equals, and then -40 plus 120 is 80. So notice it works, right? These are equal. So that's one way we could always check to make sure that this answer is correct, that we should be able to plug the points in and make sure that it works. Okay, make sure that it produces a correct statement. So, question 6. A 10th grader named Lisa sends 40 text messages per day. Based on our equation, how many minutes is she predicted to be able to do homework without interruption? Again, I don't like it written like this. I'm going to rewrite it as y equals -2x plus 120. So here, she sends 40 text messages per day. So that tells us our x coordinate. And we want to know how many minutes we predict that she'll be able to concentrate. So that'll be y equals and I'm going to replace the x with this. -2 times 40 plus 120. So that'll be y equals -80, right? Because -2 times 40 is -80. Then plus 120. And what does that equal? That equals 40. So if she sends 40 text messages per day, we expect her to be able to concentrate for 40 minutes. Now, before we go into the next question, what I want to do is I want to go, so that means 40 comma 40 is a point on our equation, right? 40 comma 40, 40 for the x, 40 for the y. So let's go ahead and look at our line that we had a few pages ago. Notice 40 comma 40. Yes, that is a point on our line, isn't it? Okay, so that's another way we can always, this should all line up, right? 40 comma 40 is a solution for this line, which is good. That's how we know that that's correct, right? Let's take a look at number 7 here. A 12th grader named Corey sends 5 text messages per day. Based on our predictive equation, y equals, and again, I'm going to rewrite that, y equals -2x plus 120. How many minutes should Corey be able to focus on his homework? So here we're going to replace the x coordinate with 5. And then we're going to figure out how many minutes he'll be able to concentrate. So again, replacing the x with 5 in this equation. Okay, I want you to go ahead and finish that one up and let me know, put the answer right here. Okay, so let's do another one like that, where we're given a bunch of data, a bunch of coordinate points, and we need to figure out the equation that models that data. Okay, so let's go ahead and look at this next question here. It says, John, the same student that came up with the text message theory, came up with another interesting topic to research 2 weeks ago. He wanted to know if going to college or any kind of schooling after high school really does increase a person's salary. He researched 5 people that he knows and charted his data in the table below. So you can see the data there. So, for example, the first person he asked, Jimmy, he had 3 years of schooling after high school, and here's how much money he makes. And you can see the rest of the data there. Now, I do want to mention that this data, as well as the data we did with the text messages and being able to study, those produce perfect lines. But usually when you get real data from people or just real data in general, it won't make a perfectly straight line usually, okay? Most of the time it'll be like a bunch of points that look like they're forming a straight line, but they won't always be perfectly on the straight line, okay? So I just want you to keep in mind that real data does not act this nicely. So this is the simplest example. We're pretending basically that the data that we get is actually really nice, okay? But yeah, real data does not usually form a straight line like this usually. Okay. Okay, so basically we were going to make these into XY coordinates. So here's our X. This is our X axis. This is our Y coordinates here. So 3 comma 50,000, 1 comma 40,000, so on. Okay, you see we made those coordinate points. Let's go ahead and graph them. So 3 comma 50,000. So 3 on the X, 50,000 on the Y. Notice 50,000 is not shown here, but we know it's between 40,000 and 60,000. So 3 comma 50,000 is right here. 1 comma 40,000. 6 comma 65,000. 6 comma 65,000. So here's 60,000. 65 is going to be right here. Okay. right? Because remember, this is like 70,000 right here, where this line is. So 65,000 is between these two. 0, 35,000. And notice our points are all lining up. That's good. That's good. 8, 75,000. 8, 75,000. Now notice they form a straight line. That's good. That's good. In other words, there will be a linear equation that will show this data. Okay. Take a look at the coordinates for Andrea and Jimmy. So we have Andrea's and Jimmy's. You may see that Jimmy went to 2 more years of school than Andrea. Okay. So for the increase in the x, so how much was increased on the x? Well, that's +2, right? Okay, so +2. So that would be your run. Remember, for the slope, we do the rise over run. And the slope is the rise divided by the run. Okay, in our case, and for the run, you always look for the x. Oh, the wrong thing here. So they gave us the x. For the rise, for the run, they already gave us that. That's 2, right? The run is always the change in x. So it went from 1 to 3, so that's +2. That's your change in x, your run. The rise is the y. So we went from 40,000 to 50,000. So that's going to be a rise of 10,000. $10,000 increase between Jimmy's salary and Andrea's salary. So we can calculate this slope. The rise was 10,000. The run is 2. So 10,000 divided by 2 is 5,000. So our slope is 5,000. Okay, that's what they got here. Now you could always just look at your graph as well. Notice, like, if I'm going from, in this case, I went from this point to this point. Notice how much do we rise? Well, we rise 10,000, didn't we? And how much do we run? 2 years. Okay, the rise over the run, that's going to be 10,000 divided by 2, the rise over run. Now we should get the same slope no matter which 2 points we pick. So if we're going from Jimmy to Rick, Jimmy's point again was 3, 50,000. Maybe don't put a comma here because we use our comma to show the difference in points here from x to y coordinate. That's what we use commas for here. So don't put a comma in 50,000. And then Rick's was 875,000. So for Rick, that's 8, 75,000. Okay. What was the increase in school years? So that was an increase of 5 years in school. And what's the increase in salary? 25,000 is the increase in salary. So when we find the slope, it's the change in y over the change in x. So that'll give us $5,000 slope. 5,000 is the slope, which is the same slope we found up here, isn't it? Okay, that's how we know it's correct. It should be the same slope throughout the entire line. So no matter which 2 points you pick, you should get the same slope no matter what. That's how you know it's a straight line. Okay, so our equation is y equals mx plus b. Our m, in other words, our slope, is 5,000. Y equals 5,000 x plus, and then what's the y-intercept? So when we look at our graph, the y-intercept is where it crosses the y-axis. So that's going to be 35,000. So our y-intercept is 35,000. Okay, and you can see here's the equation there as well. And you can make sure that this is the correct equation by plugging in these points as well. Notice they plugged in Jimmy's here again. So replacing X and Y, replace the X with 3 and the Y with 50,000, and you should get correct here, and you do. Okay. All right. I'm going to go to lunch, and I'll be right back. Okay, and we're back. So let's go ahead and start this next problem. It says, using the previous two examples as your guide, derive an equation for the relationship between the number of minutes a person flosses their teeth per day and the number of cavities they have. First, graph the data in the table below, then determine the slope and the y-intercept of your graph to derive an equation from scratch. Okay, so let's go ahead and graph these points. So 6, 0, and so that's going to be 6 on the x, 0 on the y. So that's right here. Remember, the x-axis is the horizontal. The y-axis is vertical. 2, 8. And again, all these points should line up. 0, 12. Right here. 4, 4. 4, 4. And 5, 2. 5, 2. And you know you did it correct if all your points are forming a straight line, which they are. So that's great. So let's go ahead and pick 2 points. You can pick any 2 points that you have on your graph. So I'm just going to go ahead and pick, let's just go ahead and pick the first 2, 6, 0, 2, 8. 6, 0. And 2, 8. Now, it doesn't matter which 2 points you pick because the slope should come out the same no matter which 2 points you pick. So we need to figure out the rise and the run. So it went from 0 to 8 on the y. Okay, so that would be, the rise would be 8 in that case, because 8 minus 0 is 8. And then the run, it went from 6 to 2. So that's down 4, okay? Or negative 4. So the rise over run, so the rise is 8, and the run is negative 4. So 8 divided by negative 4, that's negative 2. Okay? So we do 8, negative 4. So our equation is y equals negative 2x. Now we need to find the y-intercept, because remember, to write our equation, we need the, if we're doing y equals mx plus b, we need the m, which is the slope. We just found that, negative 2. And then you need the b, the y-intercept. So in our case, if we look at the y-intercept, that's going to be 12, because that's where it crosses the y-axis. That's where it intercepts the y. So 0, 12 is your y-intercept. So it's negative 2x plus 12. Now, again, you could have found the slope by just looking at the graph as well. So notice if I just pick 2 points, I could pick this one and this one. I would go down 4. Notice from 8 to 4, that's down 4. And then over 2, from 2 to 4, that's 2. So the rise is negative 4, and the run is 2. Rise over run, that gives us our slope, that's negative 2. So again, you could always just look at the graph and do it that way as well. If a person flosses 5 minutes per day, how many cavities are they predicted to have? So we're going to go ahead and use our equation, and x will be 5 because that's time. So our x will be 5, and you're going to plug, instead of x, you're going to put 5. So that's going to be y equals negative 2 times 5 plus 12. So that equals negative 10 plus 2 plus 12, which is 2. So 2 cavities. If a person has 4 cavities, then how many minutes are they predicted to be flossing every day? So here they give you the y. Okay, so here they give you the y, the number of cavities. So this is a little bit different than what we've seen before. But in our equation, we're going to replace the y with 4. Okay, so that's going to be 4 equals negative 2x plus 12. Now, here we want to solve for x. In other words, get x by itself to figure out how many minutes they're flossing. So we're going to go and subtract 12 both sides of the equation. It's going to be negative 8 equals negative 2x. Divide both sides by negative 2 to get x by itself, and that gives us that 4 equals x. So 4. So they were expected for them to be flossing 4 times per day. So that means 4 comma 4 should be a point on our graph. And indeed it is. 4 comma 4 right here is a point on our graph. Okay, great. Okay, let's move on. Okay. Before moving forward, make sure you label the origin 0, 0 on each graph ahead, as well labeling an additional 2 to 3 coordinates on each graph. Okay. Now this graph looks very weird. I would suggest not drawing your graphs like this, but here they put the y-axis here and the x-axis here. I don't know why they put the numbers along the left side. That's not normally what you're going to see. Normally you'd see these numbers along the y and then these numbers along the x. But here they just did this very strangely. So 0, 0 is right here. That's why they mentioned this, I think. But yeah, I would say darken up the x and y axis so you can clearly see where these two axes cross each other. In this case, here's 0, 0. Here's where x and y cross each other. So don't be confused. So like, for example, the point 2, 2 is right here. Okay, so it's very confusing with the numbers along the bottom and along the left side. I don't like this setup at all. But just so you know what you're looking at here. Hopefully I'm making sense. But this point right here, for example, would be 2, 1, 2, 3, 4, 2, 5, right here. Okay, so as long as you can kind of see how to read this. So let's go and find the slope of this line. So again, I can find the slope by doing the rise over run. So I could just go from any point to any other point. So I'm just going to go from this point. I'm going to go and erase this. From this point to this point. Okay, so what's the rise? The rise is 1 and the run is 2. So our slope, our m, will be the rise was 1 and the run was 2. So this has a slope of 1/2. Our y-intercept is where our line crosses the y-axis. So where does our line cross the y-axis? Well, right here at 4. So that means our y-intercept, the b, is 4. So then we can write our equation. Y equals 1/2 x plus 4, right? Y equals mx plus b. Plus 4. So our function is y equals 1/2 x plus 4. Now take the coordinate 4, 6 from the graph on the previous page and see if the equation you wrote actually gets you from x to y for this coordinate. That is, if you plug in 4 in for x in the equation you wrote, does it spit out 6 for the value of y? If it doesn't, then make sure you have the right equation. Okay, so remember our equation was y equals 1/2 x plus 4. Kind of what they're saying here is that 4, 6 is a point on our graph, right? So 4, 6 is right here. So this is 4, 6. So what they're saying is if we have the right equation, if this is indeed the correct equation, then 4, 6 should be a solution for this equation. So if we replace x with 4 and y with 6, it should produce a correct statement here. So let's go ahead and check that. We're going to replace the x with 4 and the y with 6. So 6 equals 1/2 times 4 plus 4. So if this comes out to a true statement, then we know that this is correct here. So this will be 6 equals, what's half of 4? What's half of 4? Well, that's 2. And then it still has a plus 4 over here. Okay, yes, that's true, right? 2 plus 4 does equal 6. Okay, so therefore we know that this is the correct equation. Okay, now this graph here, this one is going downwards as you go from left to right. Okay, so as you're reading from left to right, this one's going downwards. I want you to notice that. This is different than the one we did before where the slope, the line was going upwards. So this one's going downwards as you go from left to right. So how's that going to change it? So let's just pick 2 points and we're going to go ahead and find the slope. Here in this case, I would go down 1, then over 2. So our slope, our m, our rise was actually down 1, and then our run was 2. So this would be down 1 over 2, so negative 1/2. With negatives on a fraction, you could put the negative on the numerator or on the denominator, or you could put the negative in front of the fraction like this, okay? These both mean the same exact thing. I usually like to put my negative on the numerator like this, but you'll also see it with it in front of the fraction like this. So just be aware that these are the exact same thing, and you'll often see it written in both these two ways. Sometimes you'll also see the negative in the denominator, but that's more rare, but it also means the same thing. So our slope, see how they wrote it right here. So our slope is negative 1/2. Okay. Our y-intercept, so where does our line cross the y-axis? So if this is 0, 0, then that's 1, 2, 3, 4, 5, 6. So that our y-intercept, our b, is 6. So our function will be y equals negative 1/2 x plus 6. Okay. Now we're going to, like we did on the last example, we're going to check our function to make sure it's correct. So y equals negative 1/2 x plus 6, and we're going to use one of the points on the graph to make sure that it's accurate. So we're going to use this point here, negative 6, 9, and you can see that negative 6, 1, 2, 3, 4, 5, 6, 9. This is a point on the graph. So if this is the correct equation, then this point should produce a accurate statement. So here I'm going to replace the y with 9, and I'm going to replace the x with 6, or sorry, negative 6. So this will be negative 1/2 times, and I'm going to replace the x with negative 6, and then it has a plus 6. Okay, so this will be 9 equals, here a negative times a negative, that makes a positive. So I know that this will be positive, this part, this product. So what's 1/2 of 6? Well, that's 3. So 3 plus 6. So that'll be 9 equals 3 plus 6 is 9. Okay, very good. I'm going to do a brief lesson over here on how to multiply fractions. So let's say in this case, I was multiplying 1/2 times 6. You can always consider a whole number as over 1. So this would be like 1/2 times 6 over 1. And when you multiply fractions, you simply multiply the top times top. So 1 times 6. And then the bottom times the bottom, 2 times 1. And then 6 over 2 is just 3. Notice we got the same answer there, is 3. A lot of times when I'm doing times 1/2, I just think what's half of that number, and that's accurate as well. So that would be 3. Okay. And just remember, negative times a negative makes positive. Okay. Now let's take a look at these two lines. these, they call them parallel lines. So yes, these are parallel lines. And basically what that means is you have two lines, and as you can see them there, they don't touch each other. So those lines, just even if they go on forever, right? Just imagine the lines going on in both directions forever. They would still not intersect. They would still not touch each other. That's what it means to be parallel lines. Now, one way to kind of remember what parallel means is when you see this word parallel, I always see, oh, there's like 3 L's here, right? And they're all parallel to each other, right? They're all parallel to each other. So that helps me remember what that word means. Okay. But yeah, it's kind of like 2 train tracks, right? They go forever, but the 2 tracks, they don't cross, right? Or 2 rails on a train track. So let's examine a little bit about this. So first, let's look at line 1. So the blue line says, what's the slope for line 1? So we can look at any 2 points. So I'm going to look at this point and this point, and I want to find the slope. So I want to find the rise over run. So the rise is 1, and the run is 3. Okay. I always go from the left point to the right point. That's the way I always look at them, from the left point to the right point. And that kind of helps me see, helps me make fewer mistakes if I always go from the left to the right. But anyway, so that's the rise over run. So our slope for line M is 1 over 3. So slope for line 1, 1/3. What about for the y-intercept? So we're going to, again, look at line 1. What's the y-intercept? So what's the b? You can see here that the b, the y-intercept is 1, 2, 3, 4, right? 4 is the y-intercept. So that's right there. Now we can write our equation, right? So if we know our slope and we know our y-intercept, then we can write our equation. Y equals mx, so the slope times x, plus b, so plus the y-intercept. Let's do the same for the second line, so line 2 here. So what's our slope? So again, I could look at any 2 points and find the slope. I'm going to go ahead and choose these 2 points, let's say. And I always start with the left one, then go right. Personally, makes me make fewer mistakes that way. The rise is 1, and the run is 1, 2, 3. So our slope is 1/3. Okay. Oh, they notice anything about their slopes? And then our b in this case, 1, 2, 3, 4, -4 though, right? Because we're going down. So our y-intercept, our b is -4 in this case. So now we can write our equation. So our slope was the same, 1/3, right? They have the same slope. And our y-intercept was -4. So what's the equation of this line? Y equals 1/3 x plus -4. A lot of times when you write the equation, you won't write plus -4. You would just write -4. That means the same thing. Which statement would be the most accurate about the pair of parallel lines? So their y-intercepts are the same, but their slopes are different? No. Their slopes are the same. Yes, but the y-intercepts are different. Okay. Now, that's true for all parallel lines. Okay. We'll probably talk about this a lot, but with parallel lines, they always have the same slope. Okay. And you can kind of see that they go on in that direction forever. This one goes on in the same way forever, right? They have to have the same slope, because if you changed one of their slopes a little bit, then eventually they would cross each other, right? So yes, they have to have the same slope in order to be parallel. Okay. They are parallel if and only if they have the same slope. Okay. Let's look at this XY table from earlier in the unit. Okay. Using your logical reasoning and page turning skills to determine which equation connects X and Y for each pair in the table below. Choose the correct equation from the choices provided and write it out. Are they trying to do a joke right there? Page turning skills? Okay. Basically, they're saying they already did this problem. But we know that this will be the answer. Okay, we've done this problem before. And you could see if I replace 5 in for x and 19 for y, this will work out, right? 19 equals 4 times 5, that's 20, minus 1 is 19. This one also works for it too, right? So if I replace x with 4, 4 times 4 is 16, minus 1 gives you 15, all right? So that we know that this is a correct equation. Okay. So when I look at this equation, what's the slope? Well, you should be able to look at an equation and tell me what the slope is. Remember, the slope is always whatever's next to the x, right? Because remember, y equals mx plus b. The m is right up against the x, multiplied with the x. So the n and the m is your slope. So in this case, that's 4. And what's the y-intercept? Well, it's -1. You see, the b here is -1. Let's look at one more data from table from earlier this unit. So here's another data table. This one is a bit easier and direct than the others. See if you can figure out what the equation is and connect x and y in each pair above. Think what needs to be done to x to get each pair of y. Okay. So what do we need to do to x to get y? So how do we go from x to y? Well, hopefully you can see it's times 2 each time, right? 4 times 2 gives you 8. 6 times 2 gives you 12. So our equation would be y equals 2 times x. So 2 times whatever the value of x gives you y. Okay. What's the slope of this one? So if you think of y equals mx plus b, what's the m in this case? What's the m here? Well, the m is whatever's next to the x. So in this case, the slope, the m, is 2. What would be the y-intercept for this one? Well, notice it doesn't have a plus anything, right? So if it doesn't have a plus anything, then the y-intercept is 0, okay? So if you were to graph it, for example, it would have a y-intercept of 0, so it'll cross right here at 0, 0. Okay? And then from there, you had a slope of 2, so that's rise 2, run 1. So it would look something like this. Okay. Oh, they already graphed it for us. That's great. So, and kind of what, I'm going to darken this y and x axis here. So it has a y-intercept of 0. Okay. Now, I do want to point out that this one had a slope of 2. So when we're graphing something with a slope of like a whole number, you could always think of it as 2 over 1. So here your rise would be 2 and your run would be 1. So from your y-intercept, in this case from 0, 0, we would rise 2 and run 1. And you could draw the line there. And you can see it goes that same slope throughout the whole thing. Rise from here, rise 2, run 1. From here, rise 2, run 1. From here, you could see that it produces, using that slope, we can continue to find points along the line. Okay. All right, next page, page 28. 3 coordinates are marked off for you on each graph. One of them being the coordinate of the y-intercept. Pick any 2 coordinates out of the 3 given to determine the slope of the equation. Then use the slope and y-intercept to help you fill in the blanks to create the correct equation for the graph. You must then show your work testing out a coordinate from the graph to see if you derived the function works. See if your derived function works. Okay. So again, I want to point out that you should probably darken these axes. So the y-axis and the x-axis, they're hard to see unless you darken them up a bit. And again, they put the numbers along the left and along the bottom. I don't like that, but it is what it is. So here's 0, 0, for example. And let's go ahead and find our slope and our y-intercept. So our m, our slope, and our b. So to find our slope, we're going to use any 2 points, and we're going to do the rise over run. So I'm going to go ahead and use this point and this point. So what's the rise? 1, 2, 3, 4. So the rise is 4, and the run is 1, 2. 4 over 2, 4 divided by 2 is 2. So our slope is 2. And what about our b? What about our y-intercept? So we look at the y-axis, and I'm looking, where does our line cross the y-axis? You can see that happens at 2, 3. Okay, so our y-intercept is 3. So we have our slope and our y-intercept. Now we can write our equation. Y equals 2x plus 3. Let's go ahead and test one of the coordinate points. I'm going to go ahead and test the one that we didn't use, so this point right here. What is this point? Well, this point is -2 on the x, and then -1. So this is -2, -1. And this is the point I'm going to use to check. Now you could use any of the points on the graph, on the line, but I'm just going to go ahead and use this one here. So -2, -1. I'm going to replace the x with -2 and the y with -1. Okay. So I'm using -2, -1. And so this will be -1 equals, what's 2 times -2? Well, that's -4. And it still has a plus 3, right? So that's -1 equals, and then -4 plus 3 is -1. Okay, so this is how you check your answer. As long as you use one of the coordinate points and you plug it into the equation you got, you should get a correct statement like this, something that is actually equal. Now, if you end up getting something that's not equal, like if it said -1 equals 5 or something like that, then you know you're using, you're either messed up the equation or you messed up plugging it in. So what I would always check first is make sure that you plugged it in correctly. All right, so if you end up getting something that doesn't match here, make sure you plugged it in correctly. Then once you've kind of double checked that, I would try to make sure that the equation is correct, okay? Because either the equation's wrong or the way you plugged in the point is wrong. Also, you can make sure you're actually plugging in a point from the line. It has to be a point on the line in order for you to test it. Okay, let's take a look at this one. So here, I'm going to go ahead and use this point and this point to help me find the slope. And again, I will probably want to darken my x-axis and my y-axis here. That way it's easier for me to see what's going on. So when I'm going from here to here, again, I usually start from the left and go right when I'm finding the slope. And this will be a good example why I do that. So when I'm going from here to here, I actually have to go my rise. I don't rise to go here, right? I have to go down. So I go down 1, 2, 3, 4. So I had to go down 4. And then my run, 1, 2, will be like that. Notice this gives me a slope of -2. So when it has a negative slope, this is the reason why I always go from left to right. When there's a negative slope, my run is always still positive. I just have to worry about, did I go up or did I go down? In this case, I went down, so I know I have a negative rise. My run is still positive because I went to the right. So when we're going left to right, it'll always be positive on the bottom here. And if we're going up, then it'll be positive here. But if we go down, it's a negative here. Okay, hopefully that makes sense. I'll talk more about positive and negative slopes in a minute, though. Okay, and then where's our y-intercept? So our y-intercept is where our line crosses the y-axis. So that's right here. 1, 2, 3. Right here at -4. So that's our y-intercept, is at -4. Okay, so now we can write our equation. Y equals -2x plus -4. When I write it down here, I'm going to go ahead and write it as -2x. Instead of plus -4, I'm just going to write -4. And this is usually how you'll see it anyway. Okay, now let's use one of our coordinates here from our graph to test. So I'm going to go ahead and use I'm going to go ahead and use this point right here. I'm going to use this point right here. So what is this coordinate point? Well, on the x, it's -1, 2, 3, 4, -4, comma 4. So I'm going to use the point -4, 4. So I'm going to replace the x with -4 and the y with 4. Remember, the x always comes first, then the y. So this will be 4 equals -2 times -4 minus 4. So this will be 4 equals, what's a negative times a negative? Well, that's positive, isn't it? So that's positive 8, right? 2 times 4. And then we still have a minus 4 here. Oh, good. That works, doesn't it? 4 equals 8 minus 4 is 4. So that checks out. Very good. Okay. Let me talk a little bit about negative and positive slopes, because this one we did on the page before, page 28. This one had a positive slope of 2. So notice this one, this line right here is going up as you go from left to right. This one's going up as you read it from left to right. So if it's going up as you go from left to right, that's going to be a positive slope. However, this one is going down as you go from left to right. You see how it's going down as you go from left to right? So that would be a negative slope. So that's how you can always tell whether your slope should be positive or negative. Is it going up as you go from left to right? Or is it going down as you go from left to right? Okay. So looking at this one, do you think this one would have a positive slope or a negative slope? Well, you should see as you're going from left to right, you're going up, aren't you? So we know this will be a positive slope. All right, well, let's go ahead and solve this one. Okay, I darken my y-axis and my x-axis, and I'm going to grab 2 points and find the slope between them. So I'm going to find my rise and my run. So we use find my slope. The rise is 1, and the run is 1, 2, 3, 4. So my slope in this case is 1/4. What about our y-intercept? Well, the y-intercept in this case is down 2, right? So from 0, 0, I had to go down 2, -2. So that's -2 there. So now we have our equation. Y equals 1/4 x plus -2. Again, I'm going to write it as y equals 1/4 x minus 2. By the way, if you just write down everything I write and do everything I do, it'll help it make a lot more sense, okay? Just practice following along by writing it along, okay? And also it helps you to show all your work too. Now let's go ahead and pick one of the test coordinates to make sure that we have the correct equation. So which test coordinate do we want to use? Maybe I'll use this one right here. So what is this coordinate? This coordinate would be 1, 2, 3, 4, comma, -1. So 4, comma, -1. And let's just make sure that this point does lie on this equation. 4, -1. So we're going to replace the x with 4 and the y with -1. So -1 for y equals 1/4 times x, and we're going to replace x with 4, minus 2. So this will be -1 equals, all right, so now we need to multiply 1/4 times 4. Okay, well, hopefully you would see, oh, well, that's 1, okay, which is correct. But let me show you in case anyone needs help here. Whenever you're multiplying a fraction times a whole number, I can consider that whole number as over 1. Okay, so that'd be like 4. I could rewrite it as 4/1. And then when you're multiplying fractions, you multiply top times top, bottom times the bottom. So that gives you 4 divided by 4, which is 1. So 1/4 times 4, that gives us 1. We still have a minus 2 here. So -1 equals, and then 1 minus 2 is -1. So that checks out. That's good. Okay. So here's one more. I want you to go ahead and try to do this one on your own. But before I let you do that, I want to ask you, should this be a positive slope or a negative slope? So go ahead and see if you can find the slope of this one, find the y-intercept, write the equation, then use one of the test points to make sure that's the correct equation, okay? I just showed you 2 examples or 3 examples just like this. So if you're not sure how to do this, make sure to watch those examples once again and see if you can do them. Okay. So here it's kind of more of what we're talking about when you have an equation, y equals 2x plus 4. They're telling you the slope, aren't they? Right? The slope is 2, and they're telling you the y-intercept, in this case, 4. 2 as 2 over 1, if it helps you graph, right? We'll talk more about graphing and all that too. Okay. Now, a couple of things too. The y-intercept is always 0, something, okay? Which makes sense, right? Because if it's on the y-axis, go ahead and use a different color here. If it's on the y-axis, then, like let's say it's right here, then this would be 0 on the x, but then the y-coordinate is whatever it is, right? So the y-intercept is always 0, something. Now the x-intercept is always something, 0. So like here. So that gives you an x-coordinate, but the y-coordinate is 0. Okay. Now, when you're in this form, this is different than the form we saw before. The form that we saw before was like y equals mx plus b, right? Let me go back to blue. Blue. Y equals mx plus b. This is the form we were using this whole time so far. This is called the slope intercept form, okay? So this is known as the slope, and this is the form we've been using this whole time, slope intercept form. Okay. Now, why is it called the slope intercept form? Well, hopefully you can see it has the slope right there, and it has the y-intercept. So that's why it's called the slope intercept form. Now, we also have this form right here. This is what's called the standard form. Standard form. Okay, standard form. Notice in this case, the x and y are on the same side together, right? You see that? It has like 2x plus 3y equals 12. Now, you could always change an equation from a standard form to slope intercept. Also, you could change from slope intercept to standard. We're going to go over how to do that. But basically, the standard form, to me, this one's not as useful, right? The slope intercept form is very nice because it gives you the slope, it gives you the y-intercept, and you should be able to graph it pretty easily from there. The standard form, what it's good for is you can find the both intercepts very easily. So you can find the y-intercept, but also the x-intercept easily. And we're going to go over how to do that in greater detail. But here we're going to learn how to go from standard form, and we're going to be able to change it to slope intercept form. Okay. I don't like the way they wrote this. Let's go and rewrite this. Y equals, we usually want to put our slope first. So negative 2/3 x, and then a plus 4, because it's a positive 4. The negative goes to the 2/3. That's why it's right here. Slope is negative 2/3. Your y-intercept is 0, 4, and then you can find your x-intercept as well. Okay. So how do we go from standard form to slope intercept form? Well, I'm going to go ahead and show you with, we're going to put the work down here. So this is for the first one, 4x plus 5y equals 20. So to go into slope intercept form, basically we needed to say y equals mx plus b, right? So we want to get our y by itself. So we want to solve for y on the left side of the equation. Once we do that, then we'll be in slope-intercept form. So we want to get y by itself. So the way we're going to do that is the first step will be to subtract 4x on both sides of the equation. Okay. Remember, whatever you do on one side, you have to do on the other. So I'm going to subtract this 4x, and that's going to help us get y by itself. So we're trying to get y by itself. So here we have 5y now on the left equals, and now on the right we have negative 4x plus 20. Now I can't combine these. I can't combine these because they are not like terms, right? Notice the negative 4 has an x attached to it, but the 20 does not. So you cannot combine those, okay? So even though I'm showing like subtraction, you can't actually combine these. They are not like terms. Now the next step to get y by itself would be to divide by 5 on both sides of the equation. So every term gets divided by 5 here. So that'll be y equals, this we'll call negative 4/5 x. And then this divides evenly, so that's nice. 20 divided by 5, that's plus 4. And now you are in slope-intercept form. You see that? So that's how you go from standard form to slope-intercept form. You're just solving for y. So as you can see here, the slope is negative 4/5, and our y-intercept is 4. So our equation was y equals negative 4/5 x plus 4. So our slope, negative 4/5. That's our m, our slope. The rise over run, you would go down 4 over 5. The y-intercept, we could always write our y-intercept as 0, something. So that's what they're trying to get at. Now, our y-intercept is 4, right? So 0, 4. This is technically the proper way to write the y-intercept. Now, the x-intercept, the way you could easily find that is by noticing the x-intercept is always something, some number, put a number symbol, comma 0. Whereas the y-intercept is always 0, something. Okay. Well, the x-intercept, since it's something, comma 0, the y-coordinate will always be 0. So I know for all of these, the y-coordinate will be 0 for all of these. And I know for all of these, for all the y-intercepts, the x-coordinate will be 0. Okay. Now, how do I find that x-intercept? To me, the easiest way is to use the standard form. And what we would do is replace the y with 0. So how would that look? So I'm going to go ahead and use this standard form we had before, 4x plus 5y, but I'm going to replace the y with 0 because for the x-intercept, the y is always 0. So this 5 times 0, well, that's 0. So that just kind of just goes away. So we're left over here with 4x equals 20. Then to get x by itself, we divide both sides by 4, giving us that x equals 5. So this tells us our x-intercept is 5, 0. Okay, hopefully that makes sense. Don't worry, we're going to practice another time right here. So this is, I'm going to go and erase this here, and I'm going to do the next one in red. So this one will be question 2. I'm going to do in red. So this will be x minus y equals 3. Now again, to get it into slope-intercept form, y equals mx plus b, we need to solve for y. So we want to get y by itself. So the first thing I would do is subtract x on both sides of the equation. Negative y equals negative x plus 3. Notice the negative goes on the x. The 3 was always positive, and so it remains so. Well, am I in slope-intercept form yet? Well, not quite. I need to get rid of this negative. But if you think about it, this is like a -1 here. And we could divide everything by -1 to cancel that. This will make that into a positive y. That's good because negative over negative is positive. But that also changes both of their signs. So this -x over -1 is now positive x. And this will become a -3. So now we are in slope-intercept form. Y equals mx plus b. Y equals x minus 3. In this case, what's our slope? So what's the slope of this function? Well, if you notice, there's nothing in front of the x. Usually whatever's run in front of the x, that's our slope. Well, there's like an invisible 1 here. So in this case, our slope is 1. When you want to graph that, you do up 1 over 1, right? Because 1 over 1, basically. So your y-intercept here is -3. And we can go ahead and find our x-intercept here by going back to the standard form and replacing y with 0. So our standard form was x minus y is 3. I'm going to replace the y with 0. X minus 0 is just x. So x equals 3. So the x-intercept is 3, 0. Now this next one, they're giving us the function in slope-intercept form, right? Y equals mx plus b. So they're already telling us. I'm gonna use another color, a third color. Maybe go purple. Okay, so they're telling us the slope and the y-intercept already. So our slope is -2, and our y-intercept is 6. So 0, 6. But how do we write it in standard form? So here we have our slope-intercept form. Basically, in standard form, the x and the y are on the same side of the equation, right? See how all these, the x and the y are together on the same side? That's basically standard form. So here we have our x and y on different sides. So what we're going to do is add 2x, add 2x. So that'll give us 2x plus y on the left side. And then on the right side, we just have a 6. Okay, now we're in standard form. Notice the x and y, both variables, are on the left side. Okay, and because we have standard form, we can easily find the x-intercept of this graph, or of the line. So we would replace the y with 0. So that would be 2x plus, replace the y with 0. 2x plus 0, well, that's just 2x, right? Adding 0 doesn't really add anything. Divide both sides by 2 to get x by itself, then we'll have that x equals 3. So this one has an x-intercept of 3, 0. Okay, great. Let's move along. There's one more form we need to talk about. It's called the point-slope formula. Basically, it's another form of a linear equation, but we should be able to go from point-slope into standard or point-slope into slope-intercept. But basically, it looks like this. Y minus y sub 1 equals the slope, or m, and then multiplied by x minus x sub 1. Okay. This might look a little confusing, right? There's multiple y's going on. There's multiple x's going on. So what we need to do is just work an example, and it'll make a lot more sense. So here they give us this slope of 3/4. So that's our m. And they give us a point 4, 2. Now, what's nice about, I'm going to go back to blue here. What's nice about this slope, point-slope form, is that we can find the equation of a line if they just give us the slope and any point on the line. So if they give us the slope and any point on the line, then we can find the equation using this form. So what it would work as is the point that they give you tells you the x sub 1 and the y sub 1. Okay, x sub 1 in this case is 4, and y sub 1 is 2. By the way, we read this as, and this might be the first time you've seen this, is with a subscript. We read that, like, for example, we'd read this as y sub 1. Okay. And this would read as x sub 1. So I know I'm saying it kind of fast, x sub 1, but that's what it means. It's a subscript. Okay. And the reason we use that subscript is to denote between two different ones, right? There might be multiple x's in the same equation. So how do we determine them apart from each other? Is we'll give them subscripts. In this case, a sub 1. Same with any other variable. So you might see like, this is very common perhaps in like physics, you might have time 1 and time 2. So you have t sub 1 and t sub 2. That means the first time you're looking at and the second time you're looking at. So they both represent time, but to distinguish that they're actually two different times, you give them two subscripts. Okay, so don't freak out about that, but it'll become more and more common the further you go in math. All right, so this is the first time you might be seeing this. That's okay. But anyway, your x sub 1 is just our x coordinate, and the y sub 1 is the y coordinate for the point that we're giving here. So how do we write this point slope equation? It'll be y minus y sub 1. So that's the y coordinate. So that's 2. See, the y sub 1 is 2. Equals our m, our slope, which is 3/4. And then parentheses x minus x sub 1. So that's going to be minus 4 here. There, and you're all done. So when you're given the slope and a point on the line, then we can suddenly find the equation of the line just like that. So that's pretty useful. You can then convert it into slope intercept form pretty easily. The way you would, so let's say I want to get it into slope intercept form, which, let me remind you, that's y equals mx plus b. Erase. Y equals mx plus b. So if we want to get back to slope intercept form, we can do that pretty easily. What I would do is distribute this 3/4. So I'm going to do the work down here. So y, I'm just going to rewrite it, y minus 2 equals 3/4 x minus 4. So I would distribute this 3/4 here. So we have y minus 2 here. Distribute the 3/4, that makes 3/4 x. And then 3/4 times 4. Well, since you're doing 3 divided by 4, then times 4, those 4's cancel. So that's just going to be minus 3. Then to get y by itself, we add 2 both sides. So that'll be y equals 3/4 x minus 1. So there, now we're in slope intercept form. And so we can see our slope is the same, 3/4, and our y-intercept is -1. Y equals 3/4 x minus 1. Now, if we want, we can find more coordinate points that'll be on the line. So y equals 3/4 x plus 1. We can go ahead and replace x with 4 and find what the y coordinate would be. So for this first point, it'd be y equals 3/4 times x, so times 4, then plus 1. So that'll be y equals 3/4 times 4. Those 4's just kind of cancel each other because you're essentially saying 3 divided by 4 and then times 4. So that cancels. Dividing by 4, then times 4. Then plus 1, so that'll give you 4. So 4 comma 4 is a point on this line. Let's go ahead and do -4 here. So y equals 3/4 x, and I'm replacing the x with -4. Plus 1. So that'll be y equals, here the 4's canceled, but you're still doing a positive times a negative. So that'll be a -3, and then plus 1, which gives you -2. Okay. Now let's plug in the 8 into here, and let's find this point that goes here. So that'll be y equals, again, 3/4 x, but we're replacing x with 8, then plus 1. Oh, wait, it should have been a -1 this whole time. Why didn't you stop me? Oh, no. Oh, no. These are all wrong. That's okay. Good thing I caught it now. Okay, so this should be a 3 minus 1. That makes 2. And this one should be a -1 here. So that makes -4. And this one should be a -1 as well. Okay. So now 3/4 times 8. Just a reminder, to multiply a whole number times a fraction, you can consider the 8 as 8/1. And then you'd multiply the top times top, bottom times the bottom, and then divide. So 3 times 8, that's 24, over, and we'll put 4 in the denominator. 4 times 1 is 4. 24 divided by 4 is 6. So 3/4 times 8 is 6. 6 minus 1 is 5. Okay. And then try to plug in the last one on your own. Again, replace same equation, just replace the x with -8. All right. So now we can use that point slope formula, the one we had before. I'm going to go ahead and rewrite it so that you don't forget. The point slope formula was y minus y sub 1 equals the slope m times x minus x sub 1. Okay, so how can I use this, this form to write an equation of a line? Well, here in this example, they give us 2 coordinate points, 4, 2 and 8, 4. So 2 coordinate points on the same line. And we want to know what would be the equation that goes through both of those points. Well, what we can do is first we need to find the slope, the m. So how do we do that? Well, again, we could use the rise over run, the rise over run. So to find our slope, we could always do the rise over run. So for the rise, I look at the y coordinates. So I go from 2 to 4. So how much did we rise? Well, we rose 2. And how much did we run? We went from 4 to 8. So from 4, we go up to 8. That's a run of 4. Right? From 4, you go up to 8. That's a run of 4. Simplify this, that gives us 1/2. So that's our slope. That's our m. The rise over the run. So now that we have our slope, we can write our equation in slope intercept form. Now we could use either point that we like. I guess we're going to use point slope formula here, point slope. So we can use either point that we like. We could use the 4, 2, or we could use the 8, 4. It doesn't matter which one you pick, you'll get the same answer regardless. Okay, so let's go ahead and use that first point, 4, 2. So I'm going to this will be our x sub 1 and our y sub 1. So this will be y minus y sub 1. So that makes y minus 2 equals the slope, that's our m. So our slope was 1/2. And then we have x minus the x coordinate. So that's 4. Now we can go from this point slope form to slope intercept. Remember, slope intercept is y equals mx plus b. So how do we do that? Well, the first thing I would do is distribute this 1/2. So that would give us that y minus 2 on the left equals half x minus, what's half of 4? Oh, that's 2. Then we need to get y by itself to get in slope intercept form. So we'd add 2 to both sides to cancel this. Well, this also cancels this in this case. So y equals half x. In this case, the slope is the same as what we had here, 1/2. And the y-intercept is 0. So let's do some practice. They give us 2 coordinate points. The first thing we need to do is find the slope. So the rise over run. Okay, so for these, to find our slope, our m, that's the rise over run. In other words, the change in y divided by the change in x. Okay, and don't forget the slope intercept form, where that's going to be y equals mx plus b. Okay, so how do we find our slope? Change in y divided by the change in x. One way you can think of it too, I know I didn't point this out earlier, but we always been thinking about the rise over run, and the rise is the change in y, right? And the run is the change in x. But one thing you can do is simply subtract your y values on top, y2 minus y sub 1, over x sub 2 minus x sub 1. Okay, so this is if you're given 2 coordinate points. You could always find the slope this way, subtracting the y coordinates on top, then subtracting the x coordinates on bottom. Okay, so let's practice using this idea of the slope to help us find the slope here. So in this case, that will be m equals, and we subtract the y values on top. So I'm going to do 7 minus 5. Again, the y value is 7 minus 5. And in the denominator, we subtract the x values, 2 minus 1. So this is a straightforward way to find the rise and the run. 7 minus 5 is 2. Then 2 minus 1 is 1. So that gives us a slope of 2 over 1, which is 2. Okay. Now we are going to choose one of the coordinates from here. You could use either coordinate you want. I'm just going to go ahead and use the first one, 1, 5. But if you use the second coordinate, that's fine. And then we plug into this point slope formula. So it'll be y minus the y coordinate equals the slope, which in our case is 2, and then x minus the x coordinate. Now we can write into slope intercept form. For that, I'm going to go ahead and I'm going to do my work down here. I suggest you do the same, is kind of do some work to the side here. So this is our first question. And I want to write it as y equals mx plus b. So I want to get y by itself. But the first step will be to distribute the 2. So this would be y minus 5 equals 2 times x is 2x. And then 2 times -1 is -2. Go ahead and add 5 to both sides of the equation to get y by itself. This will give us y equals 2x plus 3. So our slope is 2, and our y-intercept is 3. You can see it's the same slope we got here. Y equals 2x plus 3. Let's do another example. So to find our slope, we can subtract the y coordinates on top. So 5 minus 4, subtracting the y coordinates. And then in the denominator, subtracting the x coordinates, 9 minus 6, giving us 1 over 3. So in this case, our slope would be rise 1, run 3. Let's go ahead and pick one of the coordinate points we like. It doesn't matter which one you pick. I'm just going to go ahead and pick the first one. Now that we have our slope and we've picked a point, we can now use the point slope formula. So y minus the y coordinate that I chose equals the slope, in this case 1/3, times x minus the x coordinate. Let's go ahead and write this into slope intercept form. So we're going to need to get y by itself here. First, distribute the 1/3. So that'll be y minus 4 equals 1/3 x minus, so 1/3 times 6. What's that going to be? Maybe to the side, I'm going to do a little bit of work here. 1/3 times 6 over 1. Multiply the numerators. 1 times 6 is 6. Multiply the denominators. 3 times 1 is 3. 6 divided by 3 is 2. Okay, so 1/3 times 6 is 2. Then to get y by itself, we're going to go and add 4 both sides of the equation. So that'll be y equals 1/3 x. -2 plus 4 is +2. Now we're in slope intercept form. Y equals 1/3 x plus 2. Okay. All right, I'm going to go and let you do the last one on your own. You've gotten 2 examples, so if you need to, go ahead and watch those examples again and see if you can do this one on your own. Okay, once you're done with that, let's move on to page 38. Here again, they put the numbers along the left and along the bottom. I don't like that, but let's go ahead and darken our y-intercept, our y-axis and the x-axis so we can see them quite clearly there. Maybe I should use a different color because the line they're using is blue. So I'm going to go ahead and use maybe this magenta color. Yeah, hopefully everyone can see that. But we want to find the slope of this line. So this is not very easy to see, I would say, but hopefully you can see on your own paper. You could choose any 2 points you want to help us find the slope. I'm going to go ahead and use this point right here and this point right here. But you could pick any 2 points that are on the line to help you find the slope. So our slope would be the rise over run. So our rise, I went up 2. So our slope, our rise was 2. And the run is also 2. So that gives you a slope of 1. So the equation for this one would be y equals 1x plus the y-intercept. The y-intercept is 0. This one, the y-intercept again is 0. But let's go ahead and use 2 points to help us find the slope. So I'm going to use this point here. And let's go ahead and use this point here. So what's my rise in this case? It might be hard to see, but the rise is 1, 2, 3, 4. So for my slope, my rise is 4, and my run is 1, 2, 2. So 4 divided by 2 is 2. So this line has the equation y equals 2x plus 0. Now, usually they won't put the plus 0 because adding 0 doesn't do anything, but they just want to illustrate that the y-intercept for all these is 0. All right, let's one more. Don't mean to write that. So, all right, let's find our slope. So I'm going to use 2 points here. Maybe I'll use this point here and this point here. So this one, the rise is 1, 2, 3, 4, and the run is 1. So the rise was 4, and the run is 1. So that's just 4 as a slope. So y equals 4x. Now notice our lines. So notice the first line here. Notice how steep it is, okay? You might say, well, it's steep, but not terribly steep. This one had a slope of 1. Now this one, next one, is much steeper, isn't it? Notice its slope is 2. And this one is even steeper still, right? And it had a slope of 4. So notice as we increase the slope, that means it increases the steepness of our line, okay? So as the slope goes up in value, the graph of the equation gets steeper. So the line gets steeper as you increase the slope. Okay, hopefully you can see that there. So you can imagine how steep a line would be if it had a slope of 10. That means it would rise 10, and then only go over 1, and then rise 10 and only go over 1. You can imagine how steep that one would be, right? Okay. How about these ones? So again, let's take a look here. Let's find our slope. So I'm going to use this point and this point here. You could use any 2 points on the line, but in this case, our slope, I go up 2 and over 2. So our slope is 2 over 2, which is 1. So the slope is 1. Okay, so this is the same exact equation that we got on the first one on the last page. Okay. Now, what about this next one? So again, our y-intercept is 0, but let's find our slope. So I'm going to use 2 points here. I'm going to go and use this point and maybe this point here. So here my rise would be 2, and my run is 1, 2, 3, 4. So my slope, my rise was 2, and my slope is, or my run is 4. So rise was 2, run is 4. Let's go ahead and simplify this fraction. I can divide both numerator and denominator by 2. So dividing both top and bottom by 2 gives us 1/2. So this one has a slope of 1/2. Okay. Let's do one more. So this one, let's take a look. What's our slope here? Again, here's my y-axis, and here's my x-axis. Okay, so I'm going to go ahead and choose 2 points. Maybe I'll use this point here and this point here. So my rise is 1, and my run is 1, 2, 3, 4. So this one has a slope of 1/4. Okay, notice the first one had a slope of 1. The next one had a slope of 1/2, and the next one had a slope of 1/4. And notice how steep the lines are. So again, we have the slope of 1. Notice the slope of 1/2 is flatter, right? It's less steep. And then 1/4 is flatter still. So as the slope gets smaller, the function gets flatter, okay? As the slope gets closer and closer to 0, then the line gets flatter and flatter and flatter, okay? Notice this one has a negative slope. Notice you're going down as you go from left to right. Again, I'm going to highlight our y-axis and our x-axis so you can see those clearly. But you can see this one has a negative slope. We talked about that before. As you go from left to right, this one's going down. So this one will have a negative slope. but let's go ahead and find the slope of this line here. So our slope will be, so from here to here, our rise will actually be going down 2 and then over 2. So down 2 over 2, which is -1. So this one has a slope of -1. I always go from left to right when I'm finding my slope. Notice we go down 2 over 1, a negative slope. Same idea for this one. I'm going to go ahead and draw the x and y axes so you can clearly see those. And let's choose any 2 points here. I'm going to go ahead and choose this point and maybe this point here. So what's our slope in this case? Well, I can see it's going to be negative because I'm going down, but how much are we going down? 1, 2, 3, 4. Down 4 over 2. Down 4 over 2. All right. -4 divided by 2 is -2. So -2x plus 0. What about here? Let's go ahead and find this one's slope. So I'm going to show the y-axis and x-axis here. Okay. Why don't you go ahead and try to find the slope on your own? Okay. So see if you can find the slope of this one and write it right here. Okay. But number 12, when you have a negative value for your slope, the graph of the equation is going down from left to right. Oh, I guess you could put downhill. Okay, down or downhill, whatever. Okay. Page 41. Let's take a look at this one. So I want to highlight our x and y axes so you can clearly see those. What's the slope of this one? Well, it's the same one we've done before, right? So if I'm looking at these 2 points, what's our slope? Should be able to do that. Okay. Should get 1x here. Now this one, again, I'm going to highlight the x and y axes. Okay. Ooh, this one's not going through 0, 0, right? All the other ones we saw up to this point were going through 0, 0. But this one is going through a different y-intercept. This one's going through +2. So our y-intercept is 2 here. Now let's go ahead and find our slope, our m, which is the rise over run. So we rise 2, run 2, 2 over 2, which is 1. So this one also has a slope of 1, but it has a different y-intercept. The y-intercept is at +2. Let's go ahead and take a look at this one. Here's the y-axis, and here's the x-axis. Our y-intercept here is at 1, 2, 3, 4. So our y-intercept, our b, is at 4. What's the slope here? So I'm going to look at these 2 points. Rise 2, run 2, 2 over 2, which is a slope of 1. So all of these have the same slope. All of these have the same slope. What about this one? Let me highlight the y-axis and the x-axis so you can clearly see them. Here, the y-intercept is right here. That's our b. Here it's 1, 2, 3, 4, but I had to go down, right? So this is actually -4 for our y-intercept. What's our slope? Well, hopefully you can see that the slope is 1 still. So fill in the blank, it's either higher or lower. The higher the value of the y-intercept, the higher the function intercepts the y-axis. Well, obviously. Okay, the higher the y-intercept, the higher the y-intercept. Surprise, surprise. The lower the y-intercept, the lower the function intercepts the y. Okay, in other words, the lower the y-intercept, the lower the y-intercept. Okay. Ooh, are we done? We're done. Okay, great. Well, I hope that all made sense. Hope you're able to follow along and write down what I wrote and and hopefully make sense of what I'm saying. If you're able to understand all that, then you're going to do quite well throughout the bookwork. But I am going to cover the bookwork in another video. So if that's up, then you can go ahead and watch that bookwork as you work on that. But if not, you're going to have to wait for that video to come out. It'll come out soon. But anyway, good luck. Take care. And if you have any questions, feel free to email me. My email is ttrigg@ofy.org. All right. Well, I'll see you guys next time. Take care.